Support comes from the Missouri Forest Products Association, providing more than 41,000 jobs in the production of wood pallets, railroad ties, white oak barrels, hardwood floors, and more. Details at choosewood.com.
Welcome to St. Louis on the Air. I'm Sarah Fensky. For years, we thought of the moon as a desert, a rocky, dry orb filled with craters, with few signs of life beyond the occasional Earthling visitors. But now we know there's water on the moon. Scientists don't know much about where it came from. As the moon formed, water could have come from Earth's volcanoes in the form of gas. It could have been brought by comets and meteorites, or it may have traveled to the surface via a solar wind that interacted with minerals on its surface to create water. Astrophysicists at Washington University in St. Louis want to find answers. The research team has been chosen as one of NASA's 8 new solar system exploration research virtual institutes. They're part of a 5-year cooperative agreement. Joining us today to talk about it is Jeff Gillis Davis. He's Associate Research Faculty in the Physics Department at Washington University in St. Louis, and he's part of this effort. Jeff, welcome to the show.
Thank you. It's good to be here.
Jeff, now for those of us who aren't space enthusiasts, why do we care about water on the moon?
The water on the moon can tell us about the origin for water on Earth. We know the moon has had an old surface, and it records the history of the early solar system. If water has been delivered by comets predominantly, then we know that maybe Earth's water was predominantly comets.
And you say that we know that maybe. Is there a strong indication that what led to water on one would also have led to it on the other?
Yeah, it's a pretty good indication. We don't know what the timing is and whether Earth formed with water, and in which case the water at the poles of the moon would actually be from volcanoes that erupted on the moon long ago. Or whether it's being formed there now by the solar wind, in which case it wouldn't tell us anything about when the Earth got its water.
So these would then be separate processes?
Yeah.
Okay. So you're looking into trying to figure out how it started there, because that could teach you all sorts of things. How do you even begin to crack a mystery like that?
Well, taking, one small step at a time. It's, sometimes daunting to look at where the end goal is, but what we would do is break it up into small, peaceable chunks, and with this survey grant, we are able to look at it from different perspectives. So I look at it through experimentation, studying how the space environment interacts with the surface of the moon and how that could create water. Another one of our scientists is looking at how the water can actually fractionate. There's different isotopes of water, predominantly oxygen 16, 17, and 18. And as they bounce around the surface of the moon, traveling from an equatorial position into the poles, those ratios will change. And what he is studying is how those ratios might change so that eventually when we get to the poles of the moon and measure the water, we would know what to expect as far as the fractionation and be able to tell whether it came from a solar wind source, a volcanic source, or whether it came from comets and meteorites.
So are you attempting to replicate these conditions in a lab, or is this more just pure math on a spreadsheet somewhere?
We're actually conducting these experiments in a lab. So we try to, faithfully reproduce the surface of the moon and understand the components that are, going on and interacting with the surface and the ices, so that we can, understand through modeling and experiment how the water got there and what to expect as far as composition.
So of these various possibilities, which do you see as potentially the most exciting?
I think one of the potentially exciting ones is that it actually came out of volcanoes from the moon, which would record a very early history of water being delivered to the Earth. And it also suggests that the poles of the moon have potentially changed slightly over the last couple billion years because of very large impacts that have changed it. We see that the water distribution is actually not isolated at the very pole of the moon right now. It's actually kind of blurred over a big area. And one of the biggest things that it may show us is that, hey, the moon has changed its pole position a little bit, and the water is actually very old and, from the inside of the moon.
So we're talking about all this water. How much water are we even talking about? Is this a few droplets here and there?
In the permanently shadowed regions, there's lots. There are 1 million to 1 billion metric tons of water at either pole, and that is equivalent to a couple million, Olympic-sized pools of water.
Okay, so it's big-sized lake.
Yeah, big-sized lake, yep.
Okay, so we've got the significant quantity of water just kind of hanging out up there. Whose water is this?
That's, one of the biggest questions is who has rights to mine this material and how it might change the surface of the moon. And that's, for lawyers somewhat to decide upon. But
Are there lawyers?
There are. There's,
I should know that. There's lawyers for everything.
There is. And what that we need to piece together is some kind of treaty and divide, from countries that do intend to go to the moon, kind of like an Antarctic treaty, what resources go to which countries. And, there are precedents for this, in mining the ocean floor or even, working and doing science in Antarctica.
And is this something that could complicate the research you're doing at this point, or?
No, the research that I'm doing is really trying to understand and how the water may have got there and how it may have changed with exposure to the space environment. Mm-hmm. So that when we go and make a measurement, we'll, absolutely know with confidence that it represents, one of the three main sources of water. And one of the big things is once we get there and start, creating bases, is this could be a potential resource for exploring the solar system.
How so?
As water, it's hydrogen and oxygen, and hydrogen is the fuel of choice for making rockets and rocket fuel. So what we have on the moon is an enabling architecture for going throughout the solar system, because if we can mine the water, we can then, make it into drinking water. We can make it into propellant to either recharge spacecraft that are already in space or use that as a launching point for, the exploration. You can go with a small spacecraft and get to the moon and then fuel up because it's very costly to launch things from the Earth. You can use the moon as kind of the base level to go throughout the solar system.
So this could become this point of future exploration taking off from the moon as opposed to just traveling to the moon.
That's correct.
You mentioned this idea of the water on the moon being a source of drinking water at some point. Do we know anything about whether the water that's there now is something that you and I could just have a cup of today and not suffer ill effects?
Right. We know so little about what the water, its state is, whether it's how much it mixed with dirt or organics or other ices. We know that there's probably carbon dioxide ice and methane ice, and how those ices interact with the space environment and what kind of organic molecules they might make. It could potentially be hazardous, especially with some of the other ices like sulfur-bearing ices, which we think might also be there. Those we would have to watch out and, come up with a plan for how to mitigate any kind of dangerous exposure.
So in addition to needing to build this base on the moon, we might have to build a water treatment plant or any number of things.
It is possible, yeah. Definitely.
You can see how these international treaties might end up becoming a bigger deal as this work continues. And it was fascinating. As I was researching this segment, I learned that 3 countries have now successfully landed on the moon, but we've had 2 recent near misses. I guess India was trying to land something,
That's
and
correct.
It just sort of disappeared.
Well, it didn't quite just disappear. They, lost contact with it, and with the Lunar Reconnaissance Orbiter, which has been in orbit around the moon for about 10 years now, it has, a stock of history images, so we were able to locate where it actually came down and, that it actually hit pretty hard and got spread across the surface of the moon. So
it literally crash landed into the moon.
It crash landed. And, that happens. And any country going to the moon for the first time has low probability of landing there safe the first time. With America history and with Ranger and Surveyor in the 60s, we were at 50%. And the first 6 Rangers that went to the moon, our first attempts, they, failed for one reason or another.
So we really can't judge India.
Definitely not. They have, a great space faring nation, and, they're our competition and
now,
friends.
Both. I saw earlier this year an article on Inverse.com noted that in the last 60 years, humans have accomplished some incredible explorations of our nightly visitor in the sky. But it has also meant that humans have inadvertently turned the moon into a cosmic junkyard. And the more countries shoot for the moon, the more space wreck is left behind. How much having these other countries and having various things crashing into the moon or people visiting it, how much is it changing the very material that you're hoping could lead to the answers that projects like yours are looking for?
One of the biggest worries is these permanently shadowed regions where the sun never shines are cold. They're 25 degrees Kelvin. So any volatiles that have gotten in there over time have stuck. That's why they're important.
And when you say a volatile, would that be
So-
detritus from a space landing? Or?
No, more gases. So water or carbon dioxide or any kind of gas that has bounced around the surface of the moon can find its way in there and get trapped for geologically long periods of time. So right now, we think it's still pretty pristine. If we start landing rockets nearby, all of that propellant that comes out of the rocket is a volatile. It's a gas and could land itself and create a layer on top of the ice that we're interested in. So, that article talked about how Apollo astronauts have left junk and spacecraft have, hit the surface of the moon. But, the surface of the moon is pretty big, so these things are not too noticeable. But we don't, of course, want to trash the moon. But one of the things that has very broad-reaching effects are, rocket plumes and the dust that they would throw up and how they might change the ice that, we're so interested in because it can tell us about the early history of the solar system.
So simply by trying to get closer to study this stuff, we might be contaminating it.
Exactly.
So what kind of steps can you take to try to mitigate something like that?
This is a new frontier that we're trying to figure out. One of the possibilities is that the rocket fuel we use is very pure and also doped with certain isotopic elements so that we can use it as a signal and not be confused with what's there and have it intermingle and not be able to kind of get off that background noise from the rocket plume.
So with this project that you guys are now doing with NASA, what kind of timeline are you on?
So we have 5 years, and in that 5 years, we plan to be able to, give NASA a good enough record of how closely you need to be able to measure the isotopic ratio of the ice to identify its source. And one of the things we're also working on is, from the remote sensing perspective, being able to map these ice distributions more accurately. Right now, we don't have a great way to map them because, again, there's no light that shines in these craters. So we're trying to come up as part of this proposal is to find more active remote sensing using lasers to identify where the ice is so that we can go to a correct location and also be able to measure its volume. Like I mentioned before, somewhere between 100 million and a billion metric tons. It's, big error bar. So being able to, narrow that down a lot more.
And that's all within the next 5 years?
Well, we're taking the steps to, make these measurements so that we can, give them the information they need to get the spacecraft. So that would be after the next 5 years.
Okay.
So we're making the fundamental measurements, and then NASA will use those, I think, to set up the criteria for the instruments that would fly on spacecraft.
So we're still looking at quite a few years before we're actually going to have this base on the moon or be drinking the water that you guys are researching on the moon.
Yeah, for big scale. But I think in the next 5 years, there's lots of these commercial lander payloads that NASA's working with that will be landing and doing some kind of proof of concept studies for in situ resource utilization, which is the use of the ice for water or making propellant, and maybe even making some measurements. So the clock is ticking, and we need to get our results so that they can inform these landers.
Well, Jeff Gillis-Davis of the Washington University NASA project, thank you so much for joining us today.
Thank you. It was great.
This is St. Louis on the Air on St. Louis Public Radio, 90.7 KWMU.
Support comes from the Missouri Forest Products Association, committed to conservation and careful management of the state's forests to make them more resilient and better habitats for wildlife. ChooseWood.com.